Introducing Portraits and Ideas. I'm Earl Gal presenting interviews to inspire and perhaps unveil something new in the realm of ideas. I would like to introduce to you today Professor Tariq Alkhalifah, who is a professor of geophysics at King Abdullah University of Science and Technology. And I would like to know what is exactly your professional position here at KAUST?
They put me in. They gave me the role to be a professor of geophysics. I'm gonna have a group here. We're gonna be working on, of course, added to our teaching assignments. So we're gonna be working on research in the particular specialities within geophysics, and this is part of what I'll do here at the university. But no special extra assignments.
Why did you decide to come to King Abdullah University of Science and Technology?
At first, I really I attended the where they put not the inauguration, where the stone. The first construction was done. It was a huge opening, and at that time I got that's my first exposure to the university. Began reading about it. I got some contact from some colleagues at UT Austin. Why not move there? And when I looked at the particulars, and especially when I attended the discovery workshop they had here in Jeddah, I think about 6-7 months ago, I got excited about it. And afterwards, they set up an appointment to review my application, as well as to review my capabilities at UT Austin. Over there, I went. It was part of a conference I attended for the Society of Exploration Geophysics, which I attend almost yearly in the U.S. And I spent 2 days afterwards at UT Austin. I presented my work, as well did a lot of interviews with the professors, and it was really interesting. Then they sent me an acceptance and an offer to join KAUST.
UT Austin, you mentioned University of Texas at Austin. That's one of the partners that KAUST has to help recruit the faculty, and of course they have been a very good partner for KAUST, and they have a very highly regarded geophysics department, and in combination with math and computational science. Is that correct?
Yeah. And they have strong people in that respect, and their focus is computational geosciences, which is really a niche or a nice part of the whole geophysics, because it's a very important part. Geophysics is, in general, is a combination of physics as well as looking into the earth, using physics to look into the earth. And physics usually embodies a lot of equations that describe phenomena, that takes especially physical phenomena that we're trying to observe. The amount of data and all the aspects related to analysis of these data is a huge importance in the geophysical community, and they are very strong in that aspect of it. Therefore, I think they were a good fit to do exactly this part, to help the university
to work with KAUST.
Yeah.
What advice would you give the youth in Saudi Arabia to promote their interest in science and pursuing science careers?
Science in general is very nice. It's very lovely. I mean, it's exciting in one regard, because it's all based on the idea of discovery. You start with something you think about. Of course, science is the tools that you need to get to that discovery. But of course, when you get enough knowledge about all aspects of a problem, you start to think about ideas of how to solve it. And the greatest reward is not actually when you get an award later or something. The great reward is when you actually find a solution and things fit, and you end up with some work that is worthy of publication. And this this part of the whole work or the whole job of doing research is probably the best part.
Yeah, the joy of discovery, as they call it.
Exactly.
I've heard several other scientists mention that moment when you really get the solution is a great reinforcer for future quests, if you will.
Definitely, it's actually an uplift for you for a couple of days.
Yes.
For some reason, the next 3 days you just feel good in everything.
That's right.
You get a high, as one would describe it in other terms. For almost 2 days.
That's right.
Unless you get some other bad news related to other things, but it's unbelievable, that feeling, because the work involved in getting to that part is usually a lot, and sometimes it's up to 6 months, a year, or even more.
Sure.
And there is actually, and it depends on the value of what you actually manage to solve or manage to find, and therefore, if it's really huge. As part of the big year, it's of course...
The bigger the problem, the bigger the joy, so to speak.
Whenever it's solved.
Exactly, when you solve that big problem. So, like, in addition to that kind of experience that you have personally had in science, what are the thoughts about science for youth that you think would be very convincing about the value of this career?
I think the other part is meeting people, because you cannot work alone. Of course, and sometimes you have to stay in your office and work a lot, but when you come out with results and go to these meetings and start showing them and interacting with people like you that are doing the same thing, it's very enjoyable and it's very nice, and you end up even when you talk about it, some people will come and discuss it with you, end up with new ideas, new possibilities, and this whole interaction of trying to deal and get together is I think it's a huge plus of this field, of doing research in general.
You're talking about a community of like-minded scholars and researchers who have a myriad of ideas that they begin to share in those sessions. Maybe you can comment on that about KAUST, because that's a part of the unique academic structure of KAUST to kind of promote this kind of interdisciplinary interaction.
Yeah, I think KAUST is doing one step further. Instead of waiting for a meeting to get together with other people that are looking at your problem from a different aspect, they're trying to create, I think, an umbrella where you're doing it within the KAUST community. Therefore, one of the things I noticed that there's hardly any barriers between the different divisions. There's a lot of interaction, and actually it's not based on and this is one thing that probably a lot of people talked about. It's not based on these colleges and departments. It's a little more open, and I see it a little more. There's a lot of opportunities for interaction between
cross-disciplinary,
which is very important, because if you cannot concentrate on your discipline to solve the problem, you might be missing a lot of other tools. And for us, the tools, for example, in geophysics, we're more an application side science. We try to more investigate what is the problem and try to find the solutions. We know some of the tools, but a lot of the tools come from the applied mathematicians, come from the computer scientists to help us to find the solutions for a certain problem.
That's right.
And you could see that in a lot of issues, especially in fluid dynamics, which is not my specialty, but in fluid dynamics, where they study, for example, the reservoirs for water and oil, that the multidisciplinary, whether you get the applied math to do the model simulation and the petroleum engineer to study a little bit of the physics, as well as geophysicists to give a more relation to the partial differential equations that control this whole dynamics. All of these multidiscipline interaction to try to solve the problem is very important. And I think here it's a very nice atmosphere to do that at KAUST.
You grew up in Saudi Arabia, and of course, all the youth in Saudi Arabia who might be watching you now, they'll say, well, here's a fellow countryman who has gone into science and technology, and he seems to be enjoying his career. Tell us about what you think the real meaning of KAUST is for the country and for the future of science in the region. The question that I was asking you, you grew up in Saudi Arabia, and you had decided to go into a science career. So you are a really good role model for the youth and students in Saudi Arabia because they see you as one of them and probably making decisions similar to how they would make decisions. So the question is, why is KAUST important for Saudi Arabia? What does it mean? And what about the future of KAUST and in the region and so forth?
Okay. Oh, thanks for the kind words. Of course, I hope I could be a positive role model to most of the people that are looking at what they're going to do with their future career. And it's very easy for a lot of to go into employment and stick with there, especially maybe the money rewards might be a lot, but sometimes it's very, very useful and very nice to think about this opportunity of getting into the whole aspect of academia and research. KAUST, I think, is going to be a very exciting, a very good example of what could happen when you really dedicate yourself to these the atmosphere, the rewards, the interaction inside. I think it's going to be a really luring example for especially for the young people here to see. Okay, if this is the atmosphere that researches, because usually research atmosphere, when people think about it, they're in these small labs, dark labs. They don't get out of these labs until they get the discovery. Of course, the way they look, the way they act is all really not the positive
stereotype. Yeah, right. In the movies.
Yeah.
Yeah, right.
But they will get a different view of it under this. I think the KAUST umbrella, whether it's the kind of equipments or the kind of facilities provided here for us, or whether it's the whole community and the way it lives, the way it interacts. Therefore, I think KAUST will be a good positive. It will be actually the positive influence for young people to really look at this option, the option of academia and continuing their education a little more. Mm-hmm. And also, the KAUST is providing opportunity by accepting students and actually educating them and getting them into the research venue, because here we have a full a graduate only university, no undergraduates. Means whoever will come here will probably end up doing research and continuing his education.
Mm-hmm. How did you reach the position you're in today in your profession? Outline your career, explain the milestones in your educational advancement, say from high school forward to the point where you acquired your Ph.D. and even the time after your Ph.D.
I think I was lucky in terms I had a very positive role model. My father, he came from a farmer's community in the north, in Al-Qasim area. And he was really chastised, or he wasn't the perfect, because they thought he was studying instead of working in the farm. And usually in the farm community we have these kind of a social system between families, between my grandfather and his brothers, and they want everybody to contribute. And unlike his cousins, he would study, which they didn't like a lot because they thought it was worthless, and he continued. And he actually continued his studies in the US and got his Ph.D. That influence affected me and my brothers and sisters, and we practically, all of us, pursued our studies to get our Ph.D. Therefore, in my case, I graduated from high school in Riyadh, went to another region, which is KFUPM, King Fahd University for Petroleum and Minerals, and got my bachelor degree in Geophysics. Worked for 3 years at KAUST, which is a research institute in Riyadh, and then had a sponsorship to continue my studies in the US. I went to Colorado School of Mines and finished my master's, got into a very strong group, the Center of Wave Phenomena with exceptional professors, and ended up doing my PhD with the research that I did turned out to be very useful research and had high impact in the industry, which was really good in essence. Then later on, I got a postdoc position at Stanford University, spent there about 2 years, and then returned back to the Research Institute, KAUST, in Riyadh, and worked there till I moved here to KAUST. I was also lucky in getting a couple of good awards, mostly on work I did in the subject of anisotropy. One of them is in 1998 I got this I got the Clarence Carter Award from this Society of Exploration Geophysics, and this is usually given to one young under 35 scientist that has contributed to the field. And then I got another award, which is in 2003. It's the Konrad Schönberger Award from the European Association for Engineer and Geoscientists. And that award is for contributions over 10 years on the field of anisotropy. Therefore, both I was really proud to get these two and happy. And and when your peers actually reward you, it's very exciting. And also a reward is KAUST accepted me here as well.
That's right. Well, obviously, when your peers give you an award, they're the ones who know the real significance of the accomplishment. Could you explain that field that you got the award in?
Oh, that was incredible. Both of them. The one in the U.S. in 1998, while I was at Stanford as a postdoc, that was really we went, me and my wife, and attended the whole ceremony. Mm-hmm. They were giving out, of course, about 10 different awards, from the top awards of somebody contributed his life to the award for young scientists, and it was nice. They had the picture come out and what this guy, okay, what everybody did, and you would go up and get the what do you call the award plaque.
The plaque. Uh-huh.
Yeah, and that was really interesting. And the other one, of course, was in Norway. EAG have their meeting in these different cities in Europe, and I wouldn't forget that meeting. That's right. I attend every EAG meeting. It's a well-attended meeting. More than 5,000 people attended, and I don't miss it. And that one actually was a memorable one.
This is the European Association of Geophysics.
Engineers and geoscientists.
Engineers and geoscientists.
It covers both the petroleum engineer and the geophysics aspect.
Well, you know, any student out there will see the fruits of your labor can result in quite an award, as well as somewhat celebrity in the field, and that's a motivation for the accomplishments that you can make. Now, go into some of the technical aspects of exactly what you were awarded for, you know.
Okay, I think the major contribution that I managed to develop or work on is the whole aspect of anisotropy. When I was at the university, people were studying anisotropy as a cause of error in processing data, because what we do is when we have we ignite a dynamite on the surface of the earth, or a vibrator or any source, it penetrates to the earth, we get reflections from the different layers, and we have sensors on the surface of the earth to sense these reflections. It's a huge operation within the oil industry, within the service companies, and so forth. And the purpose of it, of course, the major purpose, there's other purposes, is to find oil underneath. But the biggest driver is oil, underground water, other applications, but oil is the biggest one. The science is trying to develop ways to analyze and get the best image of the earth. And anisotropy is a phenomenon that takes place. It means that the wave, when it propagates, usually they approximate the propagation wave as a circular wavefront. where it's isotropic. Any direction have the same velocity. You could have a velocity different from one point to another, but in one point it's one velocity. Because of the gravity and the layering, they knew that there is this anisotropy influence. But at that time, it was an error more than it was an error that they had to deal with in analysis more than there is a solution. I think as a group at the Center with now, we managed to find solutions and use this to not only get better processing tools and get better images of the Earth, but get more information about the Earth using these parameters. Of course, now after at that time all of this was new and foreign. Now all the oil companies apply anisotropy processing, as well as the surface company, and it's a big business. And therefore, that part, as well as the paper that was published with Elliot Spankin, he was one of my advisors on the subject, is probably one of the most cited papers in geophysics. Therefore, that's how important the subject.
That was a landmark paper.
Yeah.
And what it does is actually it gives you a more accurate picture of what's really in the area that you're doing the tests with. Yeah. And so that could really mean whether you drill in that area or not drill in that area, and can have some significant impact on production, if you will. Yeah.
Yeah, that's the exciting part of geophysics. It's an adventure.
Mm-hmm.
You don't know. Nobody knows what's underneath the Earth. We're trying to look at all these physical measurements that we get, whether it's seismic, gravity, magnetic, to try to infer information. And then the company comes and decides to drill a well.
Mm-hmm.
Based on this information. The well in some regions could cost up to $100 million. Therefore, they're putting $100 million investment on drilling a well based on this information, and it's and it could be the difference between somebody getting fired or something. Of course, this is not in research in oil companies.
Sure. Yeah. In the corporate world.
In the corporate. Therefore, any misimage or you get a side, you could put the well up to 200, 300 meters away from its optimal position. Mm-hmm. And therefore, that's a huge loss.
Yes.
And this is why the business of getting a very good image is a huge business and a huge research opportunity or research area of interest.
That's right. There's a lot on the line, so to speak.
Yes.
And clearly, the people who are doing these other operations in the industry, they are depending on you, and they are depending on the accuracy of your technologies and your methodologies. And so you have that kind of, how should we say, responsibility, if you will, in your work. And the key thing that students can hear is that by being precise in your analysis of these large data sets, that every day you go to work, there's an excitement about what you do. Yes.
Exactly. There's two. Of course, we are a community that's hopefully trying to solve these problems, but of course, the people that do the processing are within the companies. Mm-hmm. Our job is to find new equations, new tools to help out resolve these problems.
That's right.
And there's a lot of them. And the industry gets it. The turnaround in geophysics from research is very fast. It's unbelievable because they're trying to find fast solutions.
Sure.
And in essence, our research is application oriented. It's not like a pure mathematician and so forth. Therefore, we're trying to take the tools or the equations that a pure mathematicians or a physicist develop in their field and try to gear it to what we're trying to do. Therefore, we sometimes act as a middleman in terms of research to help out get these formulas that will actually end up helping the companies. Of course, there has to be a middleman at the company to adopt this research.
So you actually link these rather abstract equations to the real world.
Yes.
Very, very, very significantly, because that is the practical application of what you find. Now, I'm very curious about a general idea. in your success over the years, and as a student and as a professional in the field of geophysics, how do you measure the relative advantage of hard work versus a high level of intelligence to accomplish your goal?
Oh wow. Okay. Well, I think in some way it's a mix of the two and a balance of the two. I mean, you cannot turn or go around hard work. You have to work hard to get wherever. Even if you think you're smart enough to solve things really fast. For example, in our cases, even if you end up with an idea and you end up with a solution, the hard work really is not finding sometimes a solution, because you could do that while you might be thinking about the problem while you're eating or something like that, but it is demonstrating that solution works and building the examples for that. Therefore, that's hard work no matter how intelligent one is. Therefore, there is a mixture of the two and a balance, and sometimes luck comes into it, because some people end up stumbling on interesting results or interesting ideas, and it comes sometimes from just attending meetings. For example, the difference between attending a talk. I mean, we have, for example, the SEG, the Society of Exploration and Geophysics, have 12 sessions at the same time. All of them. Of course, my interest, my specialty will end up 2 or 3. But the difference for me picking this paper versus this paper can be a difference between an idea or not, because this guy might not spark something, sure, and the other one. Therefore, there is a factor of luck where you find.
If you happen to be in the right session to get that idea. Right?
Exactly. Therefore, he would be presenting his. I said, okay, what if he did something slightly different? Mm-hmm. Because you have a different experience with, sure, something else, sure, and that's enough to really develop something new on the aspect. Therefore, a lot of things, it's a combination of
and the
things.
presenter can get an idea from you when you raise, exactly, a question.
Exactly.
Now the question is, you couldn't get that from reading the abstract, or is it really different to hear someone present it? What's the
interaction, of course, is huge.
Yeah. Hearing the other questions.
But you could get a lot of things from the abstracts, as well as from the, of course, the SEG and EAG abstracts are practically mini papers. They're, right, 4 pages. Right. A lot of other conferences would send 1 page. This one is
those are long abstracts. 4 pages.
Yeah, right. 4 pages with all the figures and so, sure, forth, and therefore it's possible. And a lot of people reference SEG and EAG abstracts are a major reference point for a lot of papers. Therefore, it's not just an abstract. Right. Therefore, it could give you some ideas, but the interaction is also very, very.
And that's how you decide which session to go to after you read the abstract.
Okay. Exactly. And of course, the name of the person helps. If you a name that is familiar to you and you know he delivers good talks, you would go to his more often than somebody that you know.
You know, the reason I asked this question about intelligence, because, physics and science in general has this reputation among students as being something only the smart students can handle. Yeah. And so, is there some degree of hope for a student who might feel that way when they really put the effort into it?
Yeah, I think, I can't say anybody that puts an effort, but a lot of people, any person that puts the effort, and they have to have a love to it. You have to, for example, in our cases, we have to like math. It's a given. If you don't like math, and liking math or having a desire of working with mathematical equations is not okay. I didn't understand, because a turn-off could be a bad teacher for a student. He had not the best teacher that turned him off to the subject. It's nothing to do with how he. Therefore, give yourself a chance to look at something like math or physics with somebody, with more than one person, and you could decide whether these subjects are really the kind of subjects you like to get in, or chemistry, or and different subjects have different features. For example, a young person that likes to memorize things, I would say, and some people have this natural ability. Not me. I'm very poor in memorizing things. They have this natural ability. I think they would be more fit in the medical field, in the parts of the medical chemistry, and so forth.
Descriptive areas.
Descriptive
area. Yeah.
If somebody's good with logic, as well as trying to try to fit based on logic, try to find. I think math is one of the areas. Of course, geometry is another thing. If you have your imagination can allow you to visualize things in 3D, in 2D, and trying to. That's also another thing. But all of this can be obtained through training. A lot of this. Natural abilities is important, but nobody knows. I mean, especially when you're at a young age, it's hard to know what is your natural ability. You have to give yourself a chance to get into these things. I have heard a lot of young people say, I hate math. It's not my... But you probably had not the best teacher, maybe. That's the problem. Not because math is bad. Actually, and this is some of the things I think young people need to take.
Yeah, so let's presuppose a student has that idea that I hate math, I can't do it.
Yeah.
What would you advise them about maybe beginning to love math? Because, you know, a lot of famous scientists, you read their biographies, you find out that they were terrible in certain subjects and then later became very proficient at it. Somehow they got through some barriers that were perceived in the beginning. So as a mathematician scientist yourself, you know, you might have some ideas that a youth could benefit from, you know, in terms of finding a way to conquer math, if you will.
My approach would be try to describe for him a physical problem that he could see in front of him in a mathematical context. And therefore he first would look at the value of math, then trying to bring something simple to see whether he really gets allured to this whole. And therefore, one of the nice things about math, of course, about applied math, is solving a problem. And I think in his life, he probably faced a lot of problems he wished he could solve. And sometimes, if somebody could put math in a simple term in which you could solve problems in your life, and it comes in very simple things. Nobody, for example, if you're confused, one of the things I do naturally, if I'm confused to, well, okay, today I'm gonna buy maybe 3 pencils, or should I buy 5 pencils? 3 or 5, and this is an example because you could do it on everything. But naturally comes from math, just take half between. Buy 4 and didn't even waste time thinking about this.
That's right.
But if you apply this in everything, and you'll notice that your life becomes much easier, because a lot of people will forget that there's a half solution to almost everything. And this is one thing that comes naturally.
Right.
If you add 2 numbers and divide over 2, that's half.
It's a way of thinking.
Yeah, it's a way of thinking.
A way of approaching life.
And you could elaborate this in almost every aspect in life. Therefore, if you're confused, well, should I go there at 1 p.m. or 2? 1:30.
Yeah, right.
But
That's
if
right.
somebody doesn't know anything about math, he probably doesn't know there's a half between.
There's a half hour in between. Right. That's right.
Or it's a possibility.
Here's a concrete instance. Okay, a student is studying for a course, and they are in an area of math in a chapter which they find a little tough, and then all of a sudden they get to a point where they really have difficulty trying to understand the concepts. Now, even mathematicians and scientists, they've run into that at some point in their career. What would you do in that situation? You know, from the point of view of advice, you know, you've obviously faced that, and you actually worked around it somehow because you got to a much higher level in math. What's your strategy?
Well, I think you have to, any problem you have to break it down to its basics, and make sure he got. One of the things that I faced when I get it is I realized I didn't really get a good enough handle of the basics around this level. And if you get a good handle and understanding, there's actually also a problem of shortcutting where you would go and just memorize. the whole problem and the solution instead of really understanding it. Because everything, I mean, this didn't come out of the mathematical rules or theories or hypotheses, didn't come out of a vacuum. It's based on people that understood something and created this. Therefore, if somebody could understand it, especially 100 years ago, I think it's possible for anybody now could understand it as well. Therefore, have to make sure that the basics are there. There's a good example. Examples is always a way to really get.
Find more examples.
Yeah, find more.
Go to another textbook. Find.
Of course,
if
it's the textbook.
Sure.
And it's a challenge because one of the most complex things is writing a textbook. It's not like writing a book because you end up writing something that somebody else is trying to learn, in essence, and you're trying to get this message across of this. Therefore, and there is good textbooks and there is not that good textbooks. Therefore, that's a very important aspect of really choosing something that will end up. But even math. I know in math there's rules where you cannot find easy examples to describe it. It just comes matrix multiplications. These kind of these rules people have to know and not. But if there's something that has a physical explanation or physical example, it's always nice to put it for the student to get a better handle.
When did you decide to become a scientist researcher? At what point in your career did that happen?
I think it came naturally from the beginning. We always talk about it, continuing education.
When you say from the beginning, was that in grade school? I mean, primary school?
Exactly,
really?
almost because our father was an example of somebody that accomplished that, and we thought we had to do the same thing. The field was interesting because.
Was his Ph.D. in geophysics as well?
No. His Ph.D. actually is international relations.
Oh, okay.
It's probably a social science.
So what about your brothers and sisters? You mentioned them getting Ph.D.s. What area, what fields of study did they?
I'm the oldest, the one just younger than me, both of them, and my sister are both computer scientists.
Oh, okay.
Therefore, one graduated from Methodist University in Dallas, and the other one, Shuruq, which is my sister, graduated from University of Michigan, Ann Arbor, Michigan.
A very accomplished family.
And our youngest sister is just graduated from dentistry school. Therefore, and she just visited the U.S. to look for a university to get. Therefore, it's not something we invented. It came
That's right.
because of.
It runs in the family.
But we had a good example, and choosing geophysics was interesting because I was at the university, and I actually was a computer science student. Initially, the first year. I skipped. They had an orientation year, which I managed to skip because I got good grades, and started directly into freshman. And this didn't give me enough time to think about where I'm heading. Therefore, when I spent halfway at the computer science, and I was good at it, somebody told me that in geophysics, you would end up working for 4 weeks, and they'll give you vacation for 2 weeks. Of course, this is field work.
That's right.
They send you out to the field. You work continuously, and
that's Aramco's policy.
Yeah,
that's right.
And therefore, I thought that was nice, getting a 2 week in a row vacation, and also talking with professors at the time. And it turned out the mixture of physics, geology, mathematics turned out to be a nice. Combination, and I liked it and continued working on it. But it was just came from just sitting and talking, and it started from this. Somebody mentioned, I heard in geophysics that you get this.
Right, that was like the moment.
Look at that.
There was a spark.
1 point changed the whole life.
That's right. That conversation, and that shows you how important it is for students to engage. To talk to other people,
talk to their teachers,
Yes.
they'll be surprised at the information that they gain, from that can stimulate them. And that goes to the point. I mean, in addition to your father, who I understand it was a major influence on your pursuing science as a career, what other things in your childhood can you point to as being key events, if you will, that really pointed you in this direction?
Another thing I don't want to forget, actually, although my mother didn't continue her studies, she of course was the instrumental in my father continue, and she actually my father wouldn't say you guys have to, she would end up, you have to be like your father. Okay. Therefore, she was really instrumental. We had him as an example, but she was the one who's making sure that we keep the promise.
That's right.
And therefore,
she was the implementer of the decision.
And therefore, she was really important at that aspect. Of course, you see the evidence of it every place. I mean, when computers came, and this is, one thing else, my father was one of the first people to get us computers. He actually got us when we were young. At that time, it was called PC Junior.
Sure.
The IBM. I don't know if you remember. This goes way back.
That goes back. Yeah, that's right.
And we shared that computer, and it was one of the first computers because computer at the time wasn't in houses.
Sure.
But this one had a couple of games as well. It was of course very slow, command line, no user interface. But it was an eye opener for us how technology was important, and the people that produce something like this, it would be nice to be part of it.
Was your father a teacher? Or?
No, he continued his job. He's actually in some aspect of the military, and he continued at that.
Right. So you were around a lot of smart people growing up as well, your father's friends and so on.
Yes.
And the peer group that you grew up with was quite influential. I mean, when you went to school in Riyadh, there was obviously a lot of competition in the schools and among the students, and that was the kind of thing where you had positive peer pressure, if you will. Right?
And you didn't have to have this environment. Of course, my father didn't even have the opposite environment around,
That's right.
And yet he got into. Therefore, I think it doesn't have to be the case that you have so you could get into this field. It's a breakthrough, and actually, I really admire the people that broke through what environment they had.
Being self-motivated.
Self-motivated, that probably didn't push them a lot. And they I think they're the real heroes in terms of getting to.
Well, in the case of your father, you mentioned that there was a lot of argument against it.
Yeah.
And yet he was very
He
determined.
was the lazy guy.
He was very determined, to get an education.
He was the lazy boy in the farm.
According to them.
Right.
That's right.
And he was studying. He wasn't lazy.
Exactly. Yeah. That was in the old days perhaps a view of study that that now has been transformed, where everybody is recognizing that study is so important.
Exactly.
For not only yourself, the family, and the country. To have scholars who are really probing deeply into various subjects.
Exactly.
And science is particularly important.
And it's becoming a proud point for families when somebody actually accomplishes something good in his education. Therefore, the atmosphere has changed a lot now.
What scientists can you point to that you remember from your youth that were sort of your heroes or your role models, or that you said, that's a very accomplished scientist. Perhaps I can be like him.
Oh,
of course.
Her. Of course, when we were young, it was like from physics, Newton and
the classical greats.
And this, of course, this one. But of course, I got a lot of influence from my professors, which they were. I was lucky to end up with among the top 2 professors in geophysics in the field of exploration seismic. John Claerbout, which was the director of the Sanford Exploration Project when I was a postdoc, is probably maybe the most influential person that gone through the whole exploration processing, maybe bar none. Therefore, he was a top, and he led the group that I was a postdoc. My professor, Ken Larner, as well, was one of the top contributors to the whole research field, as well as the teaching field in geophysics. Therefore, I was lucky enough to go through and very outstanding groups. The Center of Wave Phenomena made up of about 4 professors, 20 students almost, a couple of postdocs and research assistants, had at one time above 40 sponsors from the different companies, whether it's oil companies, service companies, as well as graphic companies and other, IBM and so forth. Therefore, they were very strong in their field. The Stanford Exploration Project, which was an older community led by John Claerbout, was also sponsored by a huge amount of. Therefore, they were very strong groups to work with, and I think they were a major influence for me to really work hard as well as produce, because we had to produce. At Stanford Exploration Project, we had to produce.
That's right.
that was really,
the key concept, productivity.
Productivity.
That's
They
right.
didn't care what time you came in or what time you came out. It's just, well, how many papers did you manage to get ready and ready for publication?
So I'm hearing that you really had a lot of direct experience with major leaders in the field in which you pursued. So that must have been a tremendous impact and influence for you. Yes,
exactly. And it was actually, it was probably by luck. When I came to KAUST School of Mines, I really didn't have a focus when I arrived there. But attending Ken Larner's class, and when we ended the class, he invited me to join Center of Wave Phenomena because he thought I did well in the class, and it started from there. And I continued my master Ph.D. and of course afterwards Stanford wanted me to join.
He recognized your talent, and he began to help you cultivate it further and to hone it in. The question that really is important here is that students should seek mentors. You know, like you found mentors, and they actually recognized your abilities, and they then cultivated your interest in certain areas, and then you advanced along for your master's and your PhD. What thoughts do you have to youth about finding mentors and finding people who can give you information and ideas? Just like this discussion, I mean, hopefully they will take some of the ideas that you're presenting now and go with them, you know?
No, I think this is one of the most important aspects, because you have to move or pursue and ask questions. Don't be shy. There's no shyness in this field, because there's too many unknowns. You get into a field and you're really raw. I mean, just getting into it. You're learning through classes and courses. The classes and courses will help you identify professors that you really could understand from them and get what they're saying. And there might be some professors that are a little bit not your type in terms of delivering whatever information they're delivering. Therefore, the classes will introduce you to the professors, and then you have to go and pursue and ask questions. Anytime you don't understand something, go and really try to get an understanding, because if you leave something behind, it will come to haunt you at a later stage in terms of the value of that science.
Go to this teacher's office.
Oh yeah.
Go to their office and talk to them.
Of course, and people didn't go for 2 reasons. Either they're it's too far, lazy, or they didn't go because they're shy. They're worried that the professor wouldn't like them bothering them. But the office hours are there for that, and they need to really use it.
How much time daily did you spend learning the skills that helped you the most in school? I mean, let's go way back, and obviously different times in school, different periods you had certain amounts of time that you spent after school studying, and then and as you got up the ladder, so to speak, it probably increased. I would assume, and so.
I didn't really do really well in high school. It's not one of the, but we were lucky enough at that time. There was so few graduates. There wasn't that much competition getting into the university when I graduated. Not like now. Now you have to be at the top 10%, almost 10% to get into a university.
Of the country.
Of any university.
That's right.
In the scientific field.
Sure.
At that time, it wasn't that strong. Therefore, in high school, it was teenage years, and I liked technology. I liked it, but it wasn't studying itself wasn't that key. Therefore, anytime you could rectify this. It's not. It's only at the bachelor degree that I began really looking closely and began to getting good grades and concentrating. It might have helped me that I changed my location, because I was in Riyadh where all my friends were at the high school, and then I moved to Eastern, and I practically left my friends. None of them did this move. Therefore, it was like a new life, and therefore I had a new chance to really reinvent the whole how I approach study and so forth. And slowly I began to get more interested in the subject. And I think the major thrust when I did my master's, I was a hard worker in any essence actually. During high school, though I was not studying as much, every summer I would find a job and work the whole summer and get some money. Therefore, that was part of what I did. Therefore, I was ready. I had the hard working.
That's
but,
right.
But I didn't pay attention.
That's right. That's right.
Yeah.
There were certain components that you were already preparing yourself for,
Yeah.
but then you had to add those new
Yeah.
components of
Exactly.
focus, if you will,
Exactly.
that would be combined with the hard
interest.
work
And
the passion and
and
interest.
passion, really. Especially when the subject came, that's when the passion started coming. And I think that therefore for me, I think hard work began before passion.
That's right.
And therefore, when I got to my master's, that's when I really became interested in the problems, in the whole phenomenon.
I think it's interesting that you mentioned to students listening that, perhaps your high school career wasn't as stellar as your later career, because that could give a lot of students the encouragement who may not be doing as well as they think they can do.
Exactly.
That hey, that can change. You change your focus, you change your strategy, and you can actually become the great student that you would hope to be.
Nothing is cumulative.
Yeah.
I mean, it's you could anytime, and this is the good part of especially when you end high school. Now, of course, it's a requirement that they do well in high school to get into a good university, and therefore they have to do that in essence, unless they're lucky in other ways, or they go to a private school and manage to cover that part. But this is now a little more of a requirement than before. But of course, even if you're good, it doesn't mean you're doing good. At the high school level, a lot of people just memorize the problems.
That's right. That's right.
But understanding the whole concept, understanding how you could get into it any time if you really, and everything depends on the mentor, especially at the beginning. If you end up with a good professor that really gets the message to you, it could be the difference between going all the way and just, I'll finish my BS and just get a job.
What were the circumstances that you experienced that were the greatest risk for you not achieving your goals? And then how did you overcome these circumstances if they existed?
Yeah, I could tell you one time I got really frustrated was with my first project at my master level. I was already with CWP, and I spent a month working on an equation that Chervini he's from the Czech Republic, a professor, and he published a paper. But however, one of the equations weren't that accurate. Therefore, I spent a month developing, based on this equation, a formula. And it didn't fit. The results didn't fit, the output didn't fit. And this is my first project, therefore it was really, and I remember I had my wife, and at that time one child, my daughter, and I got into it really heavy up to 11 at night at the school. Therefore, they even missed me during this month. And at the end, it didn't click. When I looked at it really closely, it turned out in the development, he made a slight mistake in the and I sent him a letter. I still have the letter where he said yes and thank you for pointing that. We actually didn't notice this, and he tried to show me points, and therefore this equation wouldn't be accurate. And I said, okay, but what this? And I actually went into a low for the next week or two because I thought, okay, now I spent a month, didn't get anything. What I'm gonna do?
Right.
But I think after a week or two, I managed to pick myself up and really pursue another more. I was also ambitious. The problem I was trying to solve probably was a little more complicated than my scientific background would allow me to.
That's
Therefore, I took what Ken Larner did for DMO at the time with Jack, which is migration error for anisotropy. Remember I mentioned anisotropy was an error issue.
Sure.
He studied the error for DMO. I took it and did the error for migration. Of course with his help, and at the end we ended up with a nice study of what type of errors ignoring anisotropy is causing into a process like migration. Of course, this was a stepping stone for getting into the solution of using anisotropy, which ended up being my Ph.D.
See, that's exactly what I'm leading to in that. Okay, here you ran into a problem. You spent a month and you felt that you didn't accomplish much at all. But in reality, you gained a lot of understanding, and you found the error that the professor acknowledged existed, and at the same time, although on that particular thing you might not have made the progress, but you carried, number one, the persistence. You carried the persistence over to the next project, and of course that could give a good impression to a student that even though you may run into these situations where you have difficulty, that difficulty is a part of the process.
And that actually the 1 week or 2 week after that was one of the worst weeks in my whole life because I remember even and my wife really helped me get out of that funk of saying,
that's right.
I think I have to give up almost. It was really a downer because I felt it was weird, but I didn't realize I actually learned from doing this. I learned how to carry a whole project ahead. I learned to try to develop a numerical test for it. Of course, it turned out to be wrong, but at least it's a learning process. But I didn't realize that because I wanted to get into my master's.
Well, I'm curious, why wouldn't you be getting credit for pointing out this error? Because that's obviously a major discovery. If that professor in Czechoslovakia didn't recognize that error and you pointed it out as a student, that's quite an accomplishment.
It is. You get a credit for it, but it still is not anything toward what your
major goal,
which was the thesis, and I had a limited time to finish that. Of course, we're coming similar to a lot of students here that have to really get their courses up and running with certain year with certain funding. I had the same issues at the time.
Exactly.
But I think the whole taking this new subject that was open, and Ken Larner had this example for the DMO, which was needed just to be migrated and done and worked and developed the equations for the migration was really a good opportunity. And I actually ended up, because as soon as we finished this part, I was on the reversal, on a high, because I managed to get something really important out, which is the measure. I managed to do, during my master, two other papers.
Let me just ask a question now. Suppose that other problem that you worked on that month had worked out successfully. Would you have ever gotten into the other area, DMO and so on? Would you have gotten into that, or perhaps you might have missed that opportunity?
You might be right. That's exactly, because that problem really would have taken me all the way through to my master's thesis, because it was a big problem to solve. And that would have
that diverted you to a different problem, which you ultimately were highly successful with, and you're carrying that perspective to this day, so to speak.
It's simple things that could alter
the course of events.
The course of events, and of course, yeah, that you're right in that aspect. That turned out to be a good thing.
Yeah.
In that.
Describe your most effective methods for study, and learning. You've gone through this over the years, and one of the things that happens as one goes to the level of the Ph.D., you need to have a system that you establish that fits yourself, And so a student out there, trial and error, they develop a system over time. And obviously your system could give a lot of information to a student out there who wants to put a system together.
I'm going to try to do my best. This is a
Sure.
while back because
Sure.
most of my reading now is trying to find solutions to my research, and not particularly studying. The last time is more than probably 13, 14 years ago. But at that time, I think one of the things I used to do really well is actually everything, do it as soon as I get it, before I forget. Therefore, of course, reading prior to going to class is very important, and I used to do some of that. I wouldn't confess I would do it all the time, but when I think there's something important, I would read the chapter or before I get in. And afterwards, of course, trying to solve the homework or the problem as soon as you get it is very important. And the people think, oh, you're gonna, after I finish class, it's supposed to be fun time. But actually, you'll get the fun time. It will come a little later after you finish your whatever assignments you have, because it will be much more fun or happier because you didn't have that back in your mind. You have to finish. You
have that worry that you got to get the work later. Yeah. Right.
Therefore, that's
the fun is a reward.
Yeah.
Yeah.
But in terms of research, of course, one of the best ways to find new ideas is to get exposed to other people's work and read. And this is the way to really find, and of course, it will help for you to have a base in terms of your research. When you have a base, because you create a base, then you create what you call the different branches of that base, and you begin looking at different subjects, but it becomes almost like a self-generating mechanism, because you have this base that you're really strong in and you're really ahead of the rest, because that's the nice thing about research. Researchers cannot cover everything. There's too many problems out there, and there's a lot of people that are tackling the same problem but from different methodologies. Therefore, if you're good and way ahead in your method, you could really develop over this method, develop branches to it, look at different aspects, and you will be in a role for a lot of publications for a while.
You'd be considered the go-to person for that area.
For that area,
yeah,
of
that's
course.
right.
And
that's right.
That's and Anisotropy as well is huge.
Mm-hmm.
We now, since of course even before that time, there was a workshop in Anisotropy every 2 years, attended by almost 100 people. But it was mostly concentrated on rock physics at that time. Now processing is a huge part of that meeting. But a lot of these people are looking at almost the same problems you're looking at, and therefore attending that meeting is very important to look at what everybody else is working on.
So you're interacting with the best brains on the subject in the
Yeah.
world. Now, going back to the issue of studying now, any other ideas? You mentioned some really good points. Any other ideas about what students can do? And then
my biggest pointer is just ask questions.
Okay.
And go ahead and if you have, of course, not all the time ask questions. Find the solution, read references. Always, for any class, try to find the best reference helper for that class. The book that the professor might give you might not be the best one.
Right.
Therefore, look at
excellent.
books of of equivalent or similar titles,
Mhm.
and see if one of them explains things.
I think that's a really powerful tip right there.
And this is something I used to do.
Sure.
I used to. That's why I ended up with a lot of books.
Right.
Because for every one, I would find every book around it.
Go to the library and just
Yeah.
pull them off the shelf.
And some cases, the professor would have picked the best book for and of course the professor's book or notes you have to keep in heart because that's where the examination focuses.
How important would note taking be for you? You know, in given a course when you're in a course.
It depends, of course. Yeah, it's very important. You have to put your different aspects to it and write it. And some professors provide their own notes, and it would be nice to get these notes ahead of time and begin writing your own view on these notes. That would be the optimal, in my view.
Your own opinion and
your
own
opinion
interpretation.
And everything,
Right.
and understanding of this. For example, an equation, and he described. You could write a couple of words that helps you understand what he said.
Keywords.
Keywords.
And I think going back to something you said earlier, this idea of reading material before a lecture on a subject is very important because that would illuminate what the lecture will be, and you will be kind of attuned to the information that comes out of that lecture more so than if you went in without that reading beforehand.
It might not make sense when you read it, but it will help you click when he begins talking about it a little more. You say, oh, wow, yeah, this is what... Okay.
Yeah, exactly.